Namaskar friends, welcome to Electronics Technology, YouTube channel. Topic of electronics technology news. Is analog devices powering India's next broadband revolution? A billion mobile users, slow fiber rollout, and India's millimeters wave leap. That is exactly how analog devices and its telecom partners are transforming high-speed broadband through next-gen wireless connectivity. Mr. Vivek Tyagi, far left, along with T.S. Shankar, sales director, second from the left from ADI, interacting with the press. India's mobile user base has crossed 1 billion, and most of us rely on mobile data for streaming and social media. But when it comes to work from home, online classes, or telemedicine, we all know how frustrating unstable internet speeds can be. These applications need broadband speeds above 100 megabits per second, something fiber-to-home (FTTH) networks can easily deliver. The problem is, setting up fiber in cities has been painfully slow. Permissions from municipalities, restrictions from housing societies, and the mess of overhead wires make installation both costly and time-consuming. Recently, the government of India has opened up the FR2 frequency range 2-band, 26 to 27 GHz, a high-frequency range that can transmit large amounts of data wirelessly. Instead of running fiber cables to every home, telecom companies can now beam data to small rooftop receivers on apartment buildings. These receivers then send the signal through Ethernet or Wi-Fi routers, giving us speeds between 100 and 300 megabits per second without digging roads or waiting for local approvals. At the 9th India Mobile Congress IMC 2025, Analog Devices India ADI hosted a media roundtable to discuss these new broadband possibilities. It was a good opportunity to hear directly from Vivek Tyagi, the managing director of ADI Analog Devices India, and understand how the company is supporting this shift toward wireless broadband. What stood out for me was the discussion on how millimeters wave broadband is already shaping the next phase of India's connectivity. We have seen BSNL launch a 4G network built entirely on Indian technology, and now companies like Jio AirFiber and Airtel's Stream AirFiber are taking it further using millimeters wave. Vivek said, "We support these rollouts with RF radio frequency, 3D frequency chips, and reference designs that make the setup process much faster. Normally, wired broadband installations can take days, but with this wireless approach, it can happen within hours. For consumers like us, that means quicker connections. For telecom companies, it means faster revenue generation and better broadband adoption across India, extending fiber where needed." Millimeter wave broadband is not here to replace optical fiber. It is meant to complement it by extending high-speed coverage where laying fiber is difficult, added Vivek. Early deployments use unlicensed spectrum for moderate density areas, and future rollouts will move to license bands for higher capacity and reliability. Fiber remains the backbone, and millimeters wave helps us get that last-mile connection faster. We are working on 6G-ready millimeters wave RF radio frequency modules that can plug into different motherboards. Once we validate them, we will show them to telecom operators and global equipment makers. Being present in Taiwan also allows us to partner with major OEMs, original equipment manufacturer, supporting both local and international markets, disclosed Vivek. The cost and infrastructure advantages are clear. Existing telecom towers can host millimeters wave modules with minimal changes, adding one more box to deliver high-speed connectivity. Compared to extending fiber to every home, this is more economical and makes large-scale deployment possible. Vivek said, urban clusters like Noida, Gurugram, and Bengaluru are suitable for millimeters wave, while rural areas will continue to rely on optical fiber. India's millimeters wave leap? When someone asked about the material used, Vivek said, material choice matters in millimeters wave systems. Gallium nitride (GaN) is used for high-power RF radio frequency applications above 20 watts. For lower power designs, we manage the entire RF radio frequency signal chain internally, avoiding external gallium nitride GaN components. This gives more control over design, cost, and production. We also learned that India's telecom manufacturing is expanding. Collaborations between chip designers, OEMs, original equipment manufacturer, and system integrators enable local manufacturers like VBT and Bajaj Network to use in-house RF radio frequency chipsets to build complete equipment systems. Indian companies can act as design manufacturers or telecom vendors, strengthening the domestic ecosystem under the Make in India initiative. Explaining the use of the millimeters wave technology, Vivek added, "This technology is not just for broadband. It supports industrial IoT in sectors like cement, power, and chemicals, where real-time data is needed for automation. Its low latency and high speed enable smart manufacturing and connected infrastructure." The RF radio frequency modules include programmable elements like FPGAs, field programmable gate arrays for integration with motherboards. Academic institutions like IIT Madras and IIT Hyderabad are already acting as testbeds for developing and validating high-frequency RF radio frequency technologies. We also heard that discussions are underway to explore the 60 GHz spectrum, which could support future 6G applications. Existing RF radio frequency components, such as the Apollo product line operating up to 20 GHz, can be extended to higher frequencies as standards evolve. As India moves towards smart cities, wave broadband is expected to become a crucial layer of connectivity. Once telecom operators validate the technology, it will be integrated through partnerships with equipment vendors and system integrators, working on smart city infrastructure. With government support, research collaborations, and growing broadband demand, we can see India's telecom ecosystem gearing up for the next era of connectivity. Millimeters wave technology could become a cornerstone for delivering fast, scalable, and locally developed broadband solutions, helping strengthen India's position in the global telecom landscape. Do you like this video? Please subscribe, share, like, and press bell icon for getting notifications of Electronics Technology YouTube channel. And for searching my YouTube channel, please write at the rate Electronics Technology 50.